Okay, so after our simulation's done, this is what we might see, which is our bridge quite heavily deformed due to the exaggerated deformation scale. We can also notice that this is a stress contour plot, and that's our legend, which tells us the stress values corresponding to the different colors. We can also turn on and off this deformed result by pressing this button up here. And in here we also have some plot tools, so we can take a section cut and look at the stresses inside the cross section of different areas of our bridge. We can also use the probe tool, which is pretty handy. So this lets us just select any arbitrary point and it will tell us the node number, its XYZ location, and its stress value. And yeah, we can choose multiple at a time. And if we select displacement and then probe, we will see that the value it gives us in displacement now for the probe tool. Cool, so if we just have a look at stress, if we right click this, we can edit definition and we can have a look at the different settings in here. So we're displaying the von Mises stress, and if we open that we can find all the other different kinds of stress like normal and shear and principal, but we'll just leave that as von Mises. And here we can change the units, so this is Pascal, or we can also go with the megapascal. Here we have the deformed shape scale, so we've just got that on automatic, but we can use a true scale or our own scale. In here we've got some more chart options, so we can show like the minimum and maximum point. So that would be the maximum stress here, and the minimum here. We also can change the number settings, so we can have scientific, floating, or general. So that'll change what numbers appear on our scale, and also the decimal places. We don't need to change any of these settings here. We can leave those as is. So yeah, that's the stress plot. And the same settings apply for displacement. So we can change the units and the scale. And here we have the resultant displacement, so that'll be the displacement of the node considering all the directions, so X, Y, and Z. But if we open that up, we can find a bunch of different ones, so we'll have a look at these in a minute. They're important. And here we can show the maximum displacement and stuff like that. Cool, so let's take a look at the other displacement options. So if we right click results and select define displacement plot, we can create a new displacement plot. So in here we're going to select displacement in Y. We'll leave that in millimeters, and we'll have an automatic deformation, and we'll show the minimum displacement and confirm that. So now if we have a look here, we can turn off the deform result. We can see that at this point here is our minimum displacement, only because of how we've defined it. So if we look at our legend here, because our force is applying in the negative Y direction, we're going to see that the bridge will deform a lot in this sort of area in the middle. And so our negative value corresponds to the direction of the displacement. So our minimum displacement will actually be our maximum displacement, but the negative is showing the direction. So we can see that that's here. So we're at 0.1 millimeters of displacement in this at the middle of the bridge here. So that's useful information for you. We can go ahead and create another result plot, and here we'll select the factor of safety plot. Now we need to select what components of our bridge we want to consider. So we'll select selected bodies, and now we need to choose all of the components in our model, but we're going to exclude the road again. So we'll choose all of these. Oops, we want to remove the road. And yep, road is still unselected. And now here we want to choose the criteria. So we've got von Mises or shear or normal stresses. So we'll just go with the von Mises and confirm that. So now we have our factor of safety plot. Obviously the red areas are the lowest factor of safety, so they would be the most critical areas, and then we have some small areas in here with a very high factor of safety, so they would be areas that we are relatively safe. We can also change the definition of our factor of safety if we wanted to redo some of our settings here, or change the type of stress. And so what the factor of safety is doing is showing you based on the stresses in our bridge, how far off are we from the yield of the material. So at our worst point on the bridge, if we increase the stress in one of these red areas by 41 times, then our material will yield. So that's pretty much it for setting up the FEA. In the next few classes, we'll discuss how to interpret some of these results and how you might compare them with your hand calculations. So stay tuned for that. Thank you for watching, and hope you learned something, and good luck with your bridge design and FEA.